All right, let's get started. Trends in AI for July 24. My name is Jakub Zavrel from Zeta Alpha, and I'm here with Dinos.
Hi, everyone. I'm also a research engineer at Zeta Alpha, and we have prepared a very hot show again.
Hot takes or hot progress?
Hot progress, hot summer months, although not here in the Netherlands for now, but I would say definitely hot progress, and people, there are many new papers and research methods that people want to get their hands on. So
let's dive into it.
Dive in.
We have news, not so much gossip this time, but some very cool research papers and product releases.
For sure, yeah. I think people have more or less have settled down with the competitive and kind of hypey statements. So most people are getting to building stuff, which is cool to see.
Yeah. So one of the most interesting hot off the press news items was this week's launch of Moshi by Kyutai, the Paris-based non-profit AI startup, which kind of revealed a product or open source project, which is maybe competitive with GPT-4o, right?
Well, it's for sure in the same space. So
so what does it do, actually?
It is a model that is natively multimodal in the sense that it takes audio in and produces audio out. So it's an audio language model.
Yeah,
is what they called. And yeah, the demo that they gave it was quite a shocker for me because I didn't follow this company closely before, or that they were working on such a thing.
Yeah, they are a bunch of ex-Meta AI senior engineers, like Hervé Yagou and Edward Grav.
Right, and the demo basically was you open a website, you speak to it, and it speaks to you back really fast, maybe sometimes too fast, in my opinion. If the demo is up, anyone can try it. If you visit the Kyutai website, and basically it jumps right back at you and interrupts you and speaks out in natural language, which I think the audio generation part is quite
The voice part is really good. I tried it, and it can change its tone and speed, style, and all those kind of things. But I don't think it's quite on the level of GPT-4o yet.
Right, and I don't think it's at the scale. Also in the
it's a smaller
parameter
model,
size. Yeah, but what's cool about this is it's going to be open source. So I definitely expect to see people jump on it and work and extend it even further.
It's very fast, right? So my theory is this. Because they tweaked so much on the latency part to get it to do real-time speech, I think the model is also, they must have touched some parts of the attention mechanism. So it's actually not attending so much to the whole context of the conversation. It kind of goes a little bit into loops.
Yeah, it reminds me a lot of generation of the models around GPT-J and that kind of Llama 1 performance.
Yeah. Well, it can only get better, but it's really cool that it's coming from Europe, and we're showing clearly that the talent in Europe in AI is very strong. In China, there's also a lot of AI startups and companies using LLMs, also from local Chinese vendors, and that will only increase from next week onward because OpenAI is shutting down access to GPT from mainland China.
I wonder if this has any relations to elections or politics coming up.
Well, there's an interesting piece of OpenAI drama around the board of OpenAI, which has been enlarged, and one of the new guys on the board is the former director of the NSA. So that might have something to do with it.
Yeah, I saw Edward Snowden was not very happy about this developments.
But I think it certainly means that, the whole Chinese AI scene is going to be more self-reliant, and there's going to be actually more incentive for them to produce high-quality LLMs.
Right, but I also think that in a lot of technical reports we've been reading from the development of Chinese language models, they are heavily relying on OpenAI synthetic data.
Also for generating synthetic data, yeah, so that will be a bit more difficult. But I'm thinking that a lot of VPN stuff can easily bridge that through US data centers. All right, so in other news, it's kind of a follow-up to last month's news items. There was the Apple event where they launched Apple Intelligence, and the major thing that people were waiting for is, of course, the OpenAI integration.
Right. I mean, actually, I enjoyed and have some respect for what they try to do with the local LLM, both on the iPhones and the laptops, where basically you can get some nice to have features like text correction or text reformatting, restyling. But yeah, the main heavy hitter that we kind of rumored beforehand was you're going to integrate with ChatGPT, so it's just available on Siri.
Yeah, and everybody was speculating how much money OpenAI was making from this deal. And some journalists dug into it and discovered
it's not really
zero.
It's not really a profitable deal for OpenAI. It was mostly a distribution opportunity. I also read a rumor, but I'm not. We didn't include it because it's just a rumor for now. But I think they're also planning their next steps with other LLM vendors, and I think they announced it in the event that it's not just going to be OpenAI, but as a first step, you just offer what's the best out there.
Yeah. So Apple Intelligence, by the way, not available in Europe yet.
We'll get back to this.
We'll get back to that in a bit. Because of European regulators, but also NVIDIA was for a little brief moment the most valuable company in the stock market globally, and that ended already. But also now French regulators are considering antitrust charges, which is not such a weird idea considering the monopoly position that they have and the tying of hardware and software stacks.
Right. I mean, we see French companies really stepping up and using more and more compute. So I guess it makes sense for lobbying to take place. And
do you think they will get discounts if they if they do this kind of antitrust?
I don't think so.
I doubt it. So Dream Machine, this was your news item.
We've covered a few months back now Sora, and last month we had this new Chinese model, which is supposedly open to everyone to try because Sora is still quite behind the research paywalled garden of OpenAI. But now we have a lot of new companies popping up with models like Dream Machine from Luma.
Yeah.
And I think if people just look up online, they will have also smaller models that can run on device, but are not up to speed. But generally speaking, I think a lot of new demos have popped up where people can actually put the prompts in and get videos out.
And the quality of Dream Machine, what's your verdict on that?
I would say it's pretty convincing. It's not, I don't think that it reaches the length of consistency that Sora has, because Sora was 1 minute and 1 minute 30 seconds.
Yeah.
For these, it's much shorter, but the visual quality, it was quite good.
Yeah, Sora also not available into the general public yet. There's a new bounty on AGI, right? The ARC prize. What's the ARC prize?
Basically, I think it's an engineer or the founder from Keras, which basically put up a challenge for any developer of either like a language model team, a research team, or anyone just taking a language model and using it. And the prize is basically reach 80% on this new benchmark, which involves pretty trivial tasks, like human of age 5 would be able to complete it, which is basically these kind of puzzle problems that you have. Mostly visual puzzles, right? Puzzles where you have some blocks colored in and you see.
So it's like a reasoning by analogy type of sort of IQ test thingy, right?
Exactly. It reminds me a lot of IQ, and it's pairs of images before and after, so you just have to find the continuation.
So why is this so hard?
I think it's just this multimodality included with that. It's not really in distribution for any of the training data, at least at this moment.
Yeah.
But we've also seen a lot of progress on this ever since this challenge was announced. I think it's less than a month it has been announced, and already from 30-40%, it has jumped to 60 with some advanced techniques that involve also code and tool use. So it's not exactly just reasoning from the model stuff, but kind of program synthesis.
More agentic type of architectures. So there's a 1 million prize. So if anybody feels up for it, you can be the one. In AI hardware news, Etched has made a big splash by first of all getting a fairly large investment, over $100 million investment, but they are already 2 years approximately underway, building a very transformer-specific ASIC architecture of a chip, which supposedly can do 500,000 tokens per second. So that's quite a number of order of magnitudes, even over Grok, I think.
To me, this makes quite a lot of sense. I mean, the industry is investing a lot in transformers, so this chip is exactly what most people need, at least at the current generation of models. And I mean, we're already seeing a lot of differences in alternative architectures, but everyone is just sticking to what works. And I presume that they'll still do it for many months or years to come.
Yeah, so I don't think a specific release date was announced, but somehow it was suggested that end of this year or early next year it would be available. Exciting. So I think that will definitely largely increase the number of applications of LLMs at large scale.
And more complex applications where you have this multi-agent systems that just you need throughput to be able to perform
to do
in
all
real
these
time.
Different judgments or evaluations. In startup news, Mistral continues to rock, at least on the fundraising side. They haven't released that many new models this month, but that's probably because they were busy with investors. They got 600 million euro investment, and that for a company which is 1.5 years old. There's some new startups. For example, the one from Ilya Tutskever.
Yeah, everyone was kind of waiting for these move, and I think Ilya and a bunch of people from the OpenAI super alignment team for the new company, which is called Safe Superintelligence.
Safe Superintelligence. I always kind of mix it up. Is it Safe Superintelligence or Super Safe Intelligence?
Right. So it's a company that's dedicated.
Not super safe. It's a bit safe.
It's a company dedicated to just advancing the frontier with safe and kind of responsible techniques. But also they, in their founding letter, they also stated that they're not just interested in creating this ideal setup. They also want to actually make progress. And I'm sure they have people that will be able to continue this, I guess.
I would bet that Ilya is able to build a good research team.
It branched already once off from OpenAI into Anthropic, and now it's another company, but I'm sure there's enough talent to.
Well, we'll see how they, I'm sure on the research side, they'll do great. How they will do on the product and business side is still to be seen. Because a good founding team is not always a guarantee for commercial success. For example, we reported before on the company Adapt, founded originally by some of the transformer architecture inventors. They lost those, and now the company is kind of, following inflection as an acqui-hire. So basically the whole research team has been hired by Amazon, and the company will continue to kind of exist, but
it's probably just getting the name and the people there.
So bye-bye Adapt, or who knows, they maybe return for a second turn. At least Stability AI has been granted a second turn by some private investors, including Sean Parker, which probably getting a pretty good deal on the stock and extending the lifetime of Stability after the departure of their CEO and a bit of financial trouble. Other notable investments in big startups or small startups still is a spin-off from Meta AI. So Meta AI last year basically fired all of the people working on biology applications, which kind of makes sense because Meta is not really in the life sciences department. And now they formed a new company and got 142 million funding at the seed round.
Right. It's evolutionary scale, right?
Evolutionary
and,
scale.
We have a paper about it.
And we're going to discuss one of their papers, which actually is pretty cool. Yeah. And finally, Habia in the enterprise search market for especially financial and regulatory domains raised 100 million from Andreessen Horowitz. Startups don't only raise money, they also get in trouble sometimes. I think last month we reported that Suno raised a lot of money for its song creating AI, and now they're getting sued. They're gonna be sued probably for the same amount that they raised. So let's see how that goes. And also Udio. There's more regulatory trouble for startups. Perplexity, the LLM first search engine, which has gained a lot of traction with both investors and users, has been accused of plagiarism by the publishers.
I mean, it's always a tricky legal field to just argue that you're not plagiarizing. And I think this is the reason why OpenAI is forming so many partnerships
to license the content
with news providers. But yeah, in general, any generative model will have some resemblance to either the training material or the source in the prompts.
Yeah. So other similar news is that Figma, which made quite a big announcement about its AI-driven design feature, turned it off again because it was infringing copyrights. And what else do we have on the regulatory front? Well, this is an interesting one. In Brazil, their general terms of Meta kind of stipulated that Meta could do whatever AI training it wants with the user content. And the Brazilian authorities said, no, that's not going to happen here. So they had to adjust that.
Yeah, it's opt-in by default also. And I also remember getting a notification, an email from them a few months ago asking, or not asking, it's saying this will happen unless you opt out, we'll just take your data. So I think just good warning for people to, if they're not okay with this.
And then finally, there's a lot of discussion about SB 1047, which is a California state law that was adopted recently, by the Assembly in California, but it still has to be signed into law by the governor. So there's a tremendous amount of discussion, in particular because it kind of puts all of the liability for potential harm caused by models on the creators. And creators have to go through very extensive risk assessments and risk mitigation procedures, even for derivatives of their models, which is, of course, extremely limiting especially for open source.
Right, we've seen this, I think, with Wizard.LM too, that just dropped the model and said, oh, wait, we forgot something, and the model has never seen the light of day again.
Yeah, so I think Jan LeCun is rallying the open source community to rise up against this California bill. Apple.
Yeah, what we covered before.
Tim Cook is waving goodbye to Europe. No Apple Intelligence in Europe.
Yeah,
but that's not because of the European AI Act. It's actually because of the Digital Markets Act.
I think it's a bit of bad blood that was caused with this whole regulatory obligation for them to open up the marketplace for normal mobile apps. And now they're saying, oh, well, now our device might not be able to process the customer data appropriately to enable this AI features. But I don't think that might not last for long, because also it's just losing money for Apple, right? If they cannot sell the new features and new devices to people.
I think it will be just a little stare down until one of them budges. And I think it's not going to be the EU in this case. It's my bet. All right, so in a bit of local company news here in the Netherlands, we've seen an exciting startup form which rumors have it that it's going to have its seat right here in Lab 42. CuspAI, founded by, among others, Max Welling, local University of Amsterdam machine learning professor, and former student of Geoffrey Hinton. And Geoffrey Hinton is in the advisory board.
Right.
Yeah.
And it's gotten a bunch of credibility checks from people like Jan LeCun and other people in the industry that, I mean, especially with the problem they're dealing, which is carbon capture and
Yeah,
material
so
design.
they're going to use generative AI models to basically create new materials.
Right.
And the one they're focusing on immediately is materials for carbon capture. So a very important societal problem that they're addressing. And in Eindhoven, we have Accelera AI, which is a edge device AI chip accelerator. And they backed a pretty large investment of 68 million for rolling out their chip to devices. And in Belgium, we've seen our well-known AI company TechWolf, which is basically focusing on HR and skills analysis in companies, get I think $43 million, 40 million euro investments to expand globally. And there's also some companies which are exiting, some that I know quite well. The company that I founded in 2000, TextKernel, which has been pioneering AI in recruitment, was purchased fully by recruitment vendor Bullhorn from Boston. End of a long adventure. So let's go to model releases. I think the biggest one in terms of quality and not in terms of novelty was Claude Sonnet 3.5, right?
Right, and I think this is the only closed source model that we'll be covering for this edition, which is maybe a bit surprising. But basically, this is a model, the mid-tier model that they had in terms of model size. So it used to be worse than Opus, but this 3.5 edition, which they haven't really discussed how they did it, just that it's not the best that they can achieve because this is still a relatively small and fast model. It's Sonnet 3.5, and it now outperforms even the bigger 3 Opus. They have a bunch of benchmark numbers, which might or might not mean something to people, but for sure, it just shows that it improves on a bunch of tasks like reasoning, math capabilities, coding, and all that. I think one new kind of product that they are launching with this new model is what they call artifacts, which allows you extends this notion of code execution by the language model to actually allow you to develop small applications on the browser itself. So you prompt the model, ask what you wanted to do, maybe give it an image, and then it outputs like a mini website that actually runs code that it generated.
Right.
And you can iterate on it.
And in this video, you're seeing some mini video game
that you run on the browser with some 2D graphics, which is pretty cool.
Yeah.
I think it enables a lot of people that didn't have the background to.
And is it sandboxed somehow?
Yeah, it
to
is.
Not allow any sort of like more risky code execution?
I think so, yeah. Or at least I would hope.
More from open source.
Right. Again, we see a lot of improvement on models across the board on a bunch of modalities. So starting with the top left, it's DeepSeek Coder V2. This is a very strong model on coding. As you can see on the benchmarks, the large model, which I think is 236 billion parameters, it outperforms even GPT-4o on a bunch of languages, including Python and JavaScript, which is most of the popular languages people use models for. But even their light version, which is only 16 billion, they already outperform by a large margin all the open source alternatives. But this one is a bit of a step back. But I think in general, this just enables so many capabilities, both on device and just not just from the big vendors. On a similar fashion, I would say Florence 2 is a very strong model. It's not new.
I haven't heard about that one.
It was published
what style of model is that?
It's an image, it's a VLM, similar to, I think, EDFX that we covered.
Yeah, so it's like a small multimodal model.
Right, but I think the focus here is not just on the generative part, but using the embeddings for downstream classification or other tasks like this. This is a pretty old model. It was, I think, released over a year ago, the paper, but Microsoft now came and open sourced the weights with a very permissive license.
Cool.
Yeah, it's not state of the art in any sense, but the size of it, I think it's a few 100 million parameters, makes it a very strong model.
And I think on the open source or somewhat open models, right, it has this special Gemma license, which I think doesn't include a lot of things about the data that it was trained on, or it's only weights and inference code, I think.
Right, and some other like responsibility agreements that you have to abide by whatever Google thinks is right to use a model for.
But still, it's a very strong model, Gemma 2.
And again, in two sizes. One is the 9 billion. Now we're getting in this game where you just increase the parameters slightly, but you're still on the lower end.
Yeah.
So
the 27 billion is the new one. And it seems to be a lot stronger than Llama 3, 70 billion, right?
I mean, it's just on some tasks, it draws some models perform better on other tasks, I think.
No. Llama 3 70 still outperforms it on MMLU. Yeah.
And finally, we have this new NVIDIA model, which is a giant model.
It's a huge model.
And I mean, for its size, you see in all the plots, it matches all open source alternatives, but it's not like you would expect a 10 times bigger model to perform a lot better. But it's also, I think their emphasis is on this permissive license, and the way the marketing spin they put on it is that use this model is very good for synthetic data generation. And they explicitly mention that anything you generate with it, you can use it for whatever reason.
Yeah. So it's by NVIDIA, and it only runs if you buy a really large NVIDIA DGX machine.
Probably.
And one more?
Yeah, another last edition that I think is from this week or the past few days is an Intern LM 2.5. I just included this because it performs really well on benchmarks. I don't know if this translates to either some really good technical improvements or some leakage.
Really good overfitting.
But the technical report is open source, and the weights are MIT licensed or Apache 2 licensed, so people can just use it and see if it fits their needs.
All right. So if you look at the top of the arena, it's mostly closed source models. And everybody was expecting 3.5 Sonnet from Anthropic to top the leaderboard, but it didn't happen yet.
And I mean, it's very close. I would say that these two models now are pretty much interchangeable if people just go with their favorite vendor. I've read that
16-point ELO score. Oh, it's close to being significant, I think.
Yeah, but I've seen people saying that it follows instructions better, or that it's better in Python but not in JavaScript. So obviously people just experiment and see what works for them best. I still like OpenAI's environment more because it has more features in terms of image generation and so on. But it's good to have diversity. And speaking of benchmarks, we have this new version of Open Models benchmark from Hugging Face. I remember we've covered this OpenLLM leaderboard a while back, but now what happens with all these new techniques that people just use on open models, like merging models or all these weird techniques that somehow produce stronger models, the effect that this has had is that kind of saturated, right?
Yeah.
So in this new...
As you can see in this graph here, all the lines are flattening.
And so they just came up with a new composition of benchmarks and datasets which are harder, just to make basically the leaderboard steeper, so models can advance once again.
And finally, there's maybe out of spite that they didn't reach the top of the LLMs-as ELO ranking. There's a new initiative from Anthropic for developing completely new set of third-party model evaluations, especially in areas like safety and toxicity and all that. So on GitHub. Yeah,
we have quite a few cool projects, and I think they're maturing more and more now with the stronger models backing them. I've picked up a few that have quite a rise in popularity lately. One of them is this art translator app, which is just an open source contribution that runs a local translator on device, which is really cool. And I guess quite useful for people to just be able to use any language they want in any country. And this is, I think, one of the most real world applications that AI can have already, not in the future. Similarly, this chat TTS project allows you to generate speech in a more state-of-the-art fashion, and not just this old voices we've been used to. From Microsoft also, GraphRag is quite popular.
I hear a lot of buzz around that.
I think Microsoft is just investing a bit more on it because they probably use graphs a lot internally. I haven't seen if people actually find use for this, but they're open sourcing it and making it available for everyone. Obviously, we can not include some diffusion related project. There's a bunch of them, but this one I found to be quite complete and easy to use.
The DiffSynth.
DiffSynth, yeah. And just another one is a more all-encompassing app is LibreChat, just allowing you to have a local replication of the most modern UI and capabilities that multimodal models have for chats.
With different LLM backends.
Just swapping everything out.
Yeah, and Olama was a pretty popular, or is still a pretty popular project to run local inference, but there was a very critical security flaw discovered that gave root level access, I think.
Yeah, I think it was pretty high on the CVE scale. It was patched obviously very quickly, but it just shows that once you start adding wrappers and UIs and projects that you don't know what's going on, that's always the problem with
so if you're using
software.
Olama, fix your version to the latest one, please. We're coming to conferences, and we're going. SIGIR is
just around the corner,
or just around the corner in Washington DC, 14 to 18 July, with basically a roundup of all the great papers of this year in the information retrieval area. Is really a very large language model flavored version this year. There's even like a special large language model day, and I think there's hardly a session there anymore, which where some parts of the retrieval pipeline have not been replaced by large language models, ranging from indexing all the way through to evaluation. So as soon as the papers are available, we'll be indexing them in Zeta Alpha. There's 13 workshops. One of them, we have a paper about evaluation with LLMs. And you can take a guess who is the most prolific author of all of SIGIR, which researcher has the most papers to her or his name.
For the current year?
For the current year.
Who is it?
It's somebody we know quite well here in the University of Amsterdam, Maarten de Rijke.
Right.
11 papers in SIGIR. Congratulations. And also in July, we have the International Conference on Machine Learning, this time in Europe. It's gonna draw in the last week of July around 8,000 machine learning researchers to Vienna with a staggering 2,600 papers, most of them presented as poster sessions. Only I think about 150 of them as oral presentation. It's going to be 30 workshops. So if you're not on vacation yet, please check out ICML in Vienna.
I cannot imagine what 8,000 attendees look like in a venue.
It's like a big airport full of people trying to find
the right poster.
The right poster. Again, we'll be indexing the content in Zeta Alpha soon. If you don't know Zeta Alpha yet, we're an AI platform to discover and organize knowledge for R&D teams and beyond. We provide rich functionality to do question answering using large language models based on your local and private content, organize your projects in tags and get recommendations based on that for new papers. And that's also what we're using to create this monthly roundup. And this is the landscape of all the papers in the past 30 days or so.
Right, and you'll notice there's a lot of language models, I think more than any time recently, but obviously a lot of factors play into this also. I think EMLP submissions were recently due. And a lot of other applications like robotics and multimodal learning, 3D objects, segmentation, speech, all that kind of stuff. So yeah, I think we can jump into our round of the top 10.
Yeah, it's always very difficult to select a good top 10. So we use the signals from social media and GitHub and our own flavor of what we like. And we selected 10 papers. The list of 10 papers is going to be in our website very soon.
Yep, right after the window.
And let's dive right into it. So this is a information retrieval paper. It's not at SIGIR, it's just hot off the press. And it uses basically prompts as hyperparameters. What does that mean?
Right. So usually when you train a retrieval model, the typical hyperparameters you're going to have are learning rates, number of epochs, and so on. But now, especially with this idea of synthetic data generation, more and more you have to put emphasis on how high quality this data is. So why not optimize again for this? So this is what this paper is doing. Basically taking a few labeled samples from the domain you're fine-tuning on, and using these to steer the data generation process to produce a stronger model.
So how do they do that?
So they use the DSPy framework to set as an optimizer for the prompts. They use these 10 labeled examples as a collection to create a dev set and evaluate a trained model on. So they just generate data with a prompt, produce a few prompts to have alternatives, and then kind of do hill climbing ascent on the prompts that work better for this domain, for this dev set. And yeah, what they found is that just by having these 10 examples, they can actually find a very good model that when evaluated on a completely held out set, it reflects the performance of that. Yeah.
So the way I understand it, they're basically not using these examples really to generate the prompts. The prompts are just starting from some sort of default prompt, like create a question for this document. Then you take the document collection and generate a whole large set of synthetic data. And then you train a re-ranker on that, right?
Right. So they focus on small re-rankers, I think on the 100 million parameter range. They fine-tune a bunch of models, see how they perform on these 10 examples, and then pick the best prompt and iterate a bit on this process.
So the examples are only really used to evaluate the re-rankers that have been trained on this synthetic data. And then you pick basically a prompt, you try a new prompt, and you pick the one which improves this whole iteration process.
Yeah, and this is all done by an LLM. So there's no human in the loop there, only to inject some domain knowledge. Like they benchmark on this Birko collection, which is IR tasks that are kind of complex, the objective that you're trying to do
not
the retrieval.
Typical query documents.
Right. So you inject some information there, like with Arguana is one of them, that there are arguments and counter arguments. So you just add this in the original instruction for the optimization, and then the language model will see what prompts are generated, how they perform, how it can tweak them a bit to get better in-domain performance. We have the benchmark that they use, which is not that extensive in terms of baselines. So they just compare against on these two models how it would perform if you just train on these 10 samples, if you train on some normal data splits, and how it performs with their optimization or with just the original prompt that DSPy generated. And in all cases, they see that this optimization actually works quite nicely. And interestingly enough, it even matches or gets very close to the performance of much larger models. So as we said, this process requires a lot of fine-tuning and evaluation and iteration. So they went for small models probably because of that.
It's an extremely expensive iteration, right? But because for every loop in the iteration, you need to generate new data and retrain a full new model.
Right. So they emphasize and focus on these small models, but then the performance that we see in these benchmarks especially overall, and in some, I think, like Arguana, you get much stronger performance than even a 7 billion size model that acts as a list-wise re-ranker, or even a point-wise re-ranker like Monty5 3 billion.
Yeah, Arguana is really this data set where if you figure out what the
trick,
what the trick is, then you can do much better than the generic Q&A. Yeah. All right.
Pretty cool work. And I think this whole prompt optimization paradigm is getting more and more popular as more people are getting in, and it's not exactly clear how you write good prompts, right? It's not as related to how you speak English. You have to know what English or what language the language models speak.
Works well given the instruction tuning that the model has received and all that. Yeah. So I think the next paper kind of builds that idea a little bit further, and it's a bit of a weird paper. So the basic idea is exactly the same, is that if you can generate prompts, a lot of different prompts, and then you can evaluate them, then you can pick the best one. And how do you generate new prompts? Well, basically, in this paper, they use an operator which is like a bit an analogy of error gradient. So the error is actually a critique of the LLM of the outputs of the first prompt. Right? So they collect a whole bunch of outputs of a prompt, and then let an LLM write a description of what's wrong with those outputs, and that instruction is then used to generate a new prompt. So they call this method TextGrad because they argue that it's kind of metaphorically speaking, allowing a whole collection of agents which communicate with each other through various prompts, like, for example, a retrieval agent and an answer generation agent and an evaluation agent, to backpropagate the error across the whole cascade of agents. But that is highly metaphorical, right? So they introduced this kind of mathematical notation, which looks like differentiation, but it's really just kind of chaining of prompts and going backward. They do get very nice results on, I think, 5 different tasks, ranging from coding exercises, problem solving, molecular design, and even medical application with the radiation treatment plans, and show improvements both over sort of baseline and chain of thought like reasoning, but also over DSPy. It's also a paper from Stanford, this one. And they were inspired by DSPy and by papers like Human Level Prompt Engineer, and they built on that and find that they actually improve and also kind of do a different style of optimization over DSPy.
Right, I really like this example where they show in domains that you'd not typically expect this text optimization to work, like this molecular or medical example. I find it really cool how just a method that optimizes the prompt can improve performance in such a task.
Yeah, and it's just been open source, so TextGrad is on GitHub. So I expect this line of work to capture a lot of attention and improvements in the future. Here you see the comparison with DSPy. It's quite a lot better on simple tasks like object counting. On some more complicated tasks like word sorting and GSM 8K, it's around the same, but it produces different complementary optimizations. So prompts are also used to judge LLMs.
Right, so
judging the judges. It's kind of self-fulfilling prophecy, maybe, or
well, we've definitely seen this very strong trend of people using language models as an annotator or as a judge, to kind of automate the process of evaluation. But we also have seen a lot of work that highlights problems and how these models might not always correlate with human judgment. So this study does not propose a new method to do this evaluation. It's just a meta study that assesses different aspects and models on how they perform this task.
Yeah, so they use different prompts and different brands of large language models, from weak ones to strong ones, and then look how their judgments correlate with human expert ratings, right?
Right, so they have two sets of models, one collection that they call the exam takers, or the models that just perform the task.
Yeah.
And this is usually what you replace with your own implementations or systems you want to compare. And then they have judge models, which are both open source chat models, or especially fine-tuned for this task, or just language models like GPT-4 that people commonly use. And they find which metrics kind of reveal this alignment with human preference. One of the main findings of this work is that even though on percentage agreement, which means what percent of the data the model and the human annotation agrees, this doesn't really show a lot of correlation with actual preference between models. So what works better is this Cohen kappa metric, which includes the true positives, true negatives, and false negatives in the calculation to see actually how the ranking stacks. And there are other interesting insights. It's a very long paper, but they have tidbits that people can actually practically use. And one of these is this what they call leniency bias, which is, I think we've also seen this a lot, that models tend to be more lenient and more positive about the stuff than humans are. And so they show this, that models typically will have a stronger number of claims that this is correct, even more false positives.
Positives.
Another thing that we can see in this plot here is
false negatives, because the will be a negative, but the model says it's correct.
Right. Yeah. So what we can see in this plot is actually that even some very naive metrics or naive judging models, they can tell the difference apart. So generally, people agree that these models might not produce an accurate score of what model performs, but in terms of a ranking list, it's pretty good at discerning between the first 2, 3, 4 models. And what they find here, for example, is that this symbol contains baseline, which just says if the answer contains part of the golden answer. This itself can already have a very strong correlation with the human annotation. So as you can see, for the first 6 ranks, it already finds the best 6 models.
If you have a golden
if you have, yeah. This kind of benchmark is, they focus a lot on this human annotations that exist and are very precise and highly correlated between each other.
Which is hard to do for things like summarization, question answering, translation.
So on open domain, it's still a bit tricky. Yeah, and the final finding I think that is worth highlighting from this is that models are not very good judges when it comes to underspecified answers. So I think I have it in the next animation from this. Oops. Yeah, basically models do not understand that some part of the answer is missing. So they will very easily, I think it's in this figure in the bottom, in underspecified answers where the response has only part of the answer, both GPT-4 and Llama 2 are very prone to saying, oh, this is a correct answer when in reality it's not complete. So this is something that LLM-as-Judges cannot capture as well as humans do.
So the question here is, who are all the monarchs? And one of them is missing, right? Right. I think they also show that, in fact, very strong models are much better judges than weak models, right? Which is
in terms of accuracy in correlation with human judgments.
So if you're interested in large language models as judges, there's also this quite large study across 20 different NLP tasks. Just didn't make the cut, but it's an interesting paper. So I think they also have the same kind of conclusions. It's a useful method to use LLMs-as-Judges, but don't take those numbers that they produce as truth. And in a little bit of plug for our own work at Zeta Alpha, we published this open source framework called Regilo, and at SIGIR workshop on LLM for evaluation, there's a whole workshop on this topic. We are presenting it on a study that evaluates different RAG approaches, especially RAG fusion. Moving to the next paper, there is some discussion whether RAG is still necessary when we're getting large language models that have maybe a million words, a million tokens of context. And in this study, a new benchmark is launched called Loft, which basically evaluates the performance of very large context language models when basically all the information is stuffed into the context, how good that performs. And you can, of course, then compare, for example, more simple RAG systems with systems that don't do any retrieval, but just enumerate everything in the prompt. And I think what they find is that long context models are pretty good, but of course the downside of that is that even with a million tokens, it's still only 1,000 pages of text. So if your corpus is like all of Wikipedia, it's going to be still a bit hard to stuff everything in.
Yeah, and I think we don't show this on the slide explicitly, but this is a DeepMind paper, so they kind of have some skin in the game on
exactly.
model use.
It looks a little bit like a promotional for Gemini 1.5.
Right.
And I think that's also why they developed the benchmark.
There are other things other than accuracy that matter, such as the latency, time to first token, or just the cost itself for using this technique for everything that you do that can be solved effectively from RAG, because we see that from the plots, right, from the performance of the models, it's not that it just beats the retrieval, the specialized model, which is the dashed line. It's just that it matches it effectively. So it's just saying it's moving on this paradigm that you don't need specialized models. We can have one model that does everything.
There's one exception, that's the SQL tasks, where they try to kind of count some things or make an aggregation of over all the different items that are in the context. And that's where the long context models still have some pretty large room for improvement. These are all the different tasks that are, so it's basically a collection of existing benchmarks where the number of candidates are kind of aggregated from the data set to fill the entire large context. All right. If you're interested in long context models, this is also an interesting runner-up in our selection, LongRAG, which has a fairly simple experiment. What if you simply increase the length of your context, of your chunks, and use less chunks, but longer chunks in your generation process? And they find that that produces quite a lot of improvements, which makes sense. Mixture of agents. Right. What is that?
This is a paper from people at Together AI, and it's kind of a spin on the popular mixture of experts architecture. Of course.
So this is not a network architecture.
It's a network in terms of how you chain the models together, not in the intra-layer activations. So in mixture of experts, the logic is that you have mixture of agents. The logic is you have sub-agents that take input and produce some outputs, and then you can concatenate a lot of experts or agents and feed these as input for the next layer of models.
With latent representations?
No, actually with the text. So each layer takes the output from the previous layer's agents and uses that as an aggregation to produce a new outputs. So they propose these two kinds of models, the proposers and the aggregators. The proposers are the models that basically just take input, generate text, and you don't really care if that text is correct so much as that it gives you some new perspective on the input in the question at hand. And then you have the aggregators, which are the models that really need to answer the question based on the context from all the other agents. So what they find here, first of all, they focus on open source models. So they're trying to compete with GPT-4o as a single model versus a collection of open source models. And what they find primarily here in this plot is that even though individually all of the models have kind of a capped capacity and performance for this task, just by aggregating a lot of them, you kind of get this ensemble effect that you get the best out of everything. And I think more interestingly, they offer this mixture of agents set up with different tiers of capabilities. So the smaller one is the light, which is kind of matching the cost of GPT-4o. And they find that just by using, I think, 2 layers of models and 3 experts per layer, agents per layer, you match performance of GPT-4o just with open source models. Then you can, obviously, as you scale this to more agents per layer or more layers, you kind of go beyond the cost because you still have to run these models on your own hardware or some other API. Then you go even
better AI's hardware, I would guess.
Obviously, they offer some APIs for public models, so you can get even further than GPT-4o performance. And then if you go even further and use GPT-4o as this kind of aggregator, you kind of get this state-of-the-art performance on a bunch of benchmarks like Alpaca, Eval, and MT-Bench. And it's interesting because they show which models work better as aggregators and which models work better as proposers.
Yeah.
And on this Fever, I think, not Fever, some Flame benchmark, which gives you individual aspects of the answer. So this framework is better at being complete and comprehensive compared to this single shot model that uses one model as backend.
Right, I think we have to pick up the pace a little bit. We're coming towards the end of the hour. So our other 5 papers in the selection are language modeling with editable external knowledge. Very nice paper, actually one of the ones I liked most. Too bad we don't have more time for it. Basically what it does is updating, it's a RAG setup, right? You're doing question answering from a corpus of documents, but as you're as news updates and new facts become available, it doesn't try to solve this kind of updating of the world model at retrieval time, but at indexing time. So basically at indexing time, it is retrieving facts which are affected by the new information and updating them in the index. And then at retrieval time, it becomes easier to know that if, let's say, the Queen of England died, that all of the facts connected to that in your knowledge base, which consists of documents, also need to be updated. We have the scalable MatMul-Free Language Modeling.
Yeah, this paper is kind of an aggregation of all the state-of-the-art techniques. We've seen Mamba and all these variants and BitNet. The models are basically just quantize these models
to the extreme, quantization to the extreme.
Ternary or binary activations and weights.
Yeah.
So this model just combines this aspect. Previously, it was only applied on the feed-forward layer, and this model kind of combines other techniques to also quantize the attention. So basically, everything is just element-wise products or additions instead of multiplications.
Yeah. And so if you quantize to the extreme, you open kind of the road to a whole new category of hardware, which is much more efficient.
And yeah, also they developed their own FPGA that does this very efficiently, and they show with some scaling laws, I think in the next animation that, yeah, just so theoretically they haven't tried it on 2 long models that, yeah, it works decently well or matching performance.
Transformers meet neural algorithmic reasoners in one sentence.
It's a combination of graphs and language models. So you can think of Flamingo had image as input, but this has a graph as input that just merges with a language model. And they show good performance on tasks as you'd expect that have graphs as an underlying structure.
And then we have a new foundational robotics model, OpenVLA, vision, language, and action modalities combined in kind of a Frankenstein of various open source models like Llama and Dino and SIGLib. And it actually then trained on robotics and generalizes fairly well to new types of robotic embodiments. And then finally, coming back to the paper from Evolutionary Scale, which caused so much appetite for investment. Well, that makes sense because what Evolutionary Scale has done is build this ESM3 model, which is basically a protein sequence language model, a multi-aspect protein sequence language model, which is just trained on a huge amount of proteins and kind of learns to understand the grammar and the semantics of how proteins are built, but not like AlphaFold with the aim of analyzing their folding structure, but of actually synthesizing completely new proteins. And that's, of course, extremely promising, because if you can kind of give a specification of the properties or structure of a protein, and then generate both the sequence and the folding at the same time, you can basically generate new enzymes without any sort of genetic engineering. And they proved that by synthesizing a completely new fluorescent protein, which is completely different from anything known in biology. I would think it's also maybe worth some regulatory attention, because this could also be a bit dangerous. But yeah, very promising. So that brings us to the end of this episode. We have one last shout out.
Yeah, a quick project or idea to think over the weekend. Basically, this paper with schedule-free optimizers is making the rounds again. Just a way to make your training setup simpler with having one less hyperparameter, which is the learning rate schedule.
Yeah.
People are just trying it on new tasks and finding out it works, so I'll give it a try.
Look at this graph. It goes a lot faster.
And I mean, I would listen to what Karpathy has to say about it. So.
Okay, read that over the weekend. That brings us to an end. We're going to take a break over the summer, and the next edition will be on 20 September. It will actually be the Transformers at Work edition of this series, and it's going to be live from who knows. But next week we're going to San Francisco, so we're organizing a RAG fine-tuning evaluation and agent meetup in San Francisco, and we're going to be scouting if maybe who knows. Check out the papers from this month's edition in with this QR code in Zeta Alpha under this tag. And as always, enjoy discovery. Thank you.
Thank you.